Okay, welcome back once again. In this video we're going to look at variables. But first things first, we saw in one of our earlier videos that data is stored as bits, and a bit can either be a 1 or a 0. Now to make this easier for us, we refer to a collection of 8 bits as a byte. So for example, 10101111 is a byte. Let's continue and we'll look at variables. So variables are places to store values in memory. And first thing we have to look at with our variables is the different types of variables. So for us right now, we're only going to look at basic types. And basic types can be divided into two groups, integers and floating point. So integers are whole numbers, so for example 87, whereas floating numbers can have a fractional part, which means a decimal point. So for example 8.7. Now each of these groups have different types. So I've listed some of these here, not all of them, but for integers we have byte, char, int, long, and some other ones. And in floating point we have double and float. Now one thing to note is the byte type is not part of the C or C++ language, and it's just defined for the Arduino IDE. Now, why do we have all of these different types? Well, one reason is that we have different storage sizes. And the second reason is for integers, they can have different signedness. Okay? So let's have a look at this and see what that means. So, if we have a look at these types, we can see that the storage size is different for the different types. We have 1 byte for byte, 1 byte for char, 2 bytes for int, 4 bytes for long, 4 bytes for float, and 8 bytes for double. Now, with the larger storage size, the range of numbers that the type can hold changes, as can be seen here. Now, one thing to note is that byte has a range from 0 to 255, whereas char has a range of -128 to 127, even though they are both 1 byte. And this is because they have different signedness. Byte is unsigned, where char is signed. Okay? And unsigned means only positive numbers can be stored, whereas signed means both negative and positive can be stored. And floating point numbers are always signed. But what you can do with integers is you can make them unsigned by adding the keyword in unsigned in front of them. So for example, unsigned int and unsigned long. Let's continue. So we have variable types, which we know can be different sizes and have limitations on what they can store. So here I've got 2 storage spaces, okay? And we've got an int type and a char type variable. Now what I'm also going to do is I'm going to add another int type variable. Now, if I want to talk about or get something from one of these variables, how will my program know which one to use? So what we have to do is give them names. So I'm going to give them the names var1, var2, and var3. And they're variables, so they can store a value. So var1 stores -12, var2 stores 840, and var3 stores 32. Now, note that in memory these are stored as bits, and decimal is just a representation that is easy for us to understand. So, let's continue further. So, what we're going to do now is have a look at how we use this in code. So the first thing I'm going to write is int x semicolon, noting that the semicolon finishes the statement. This here creates a variable of type int with the name x, as we can see here. However, we do not know what the value is stored in this variable yet, because we haven't given it a value. Now, doing this is called declaration. Okay, so we've declared a variable. Now let's put a known value into our variable. And we can do this as x is assigned the value 2. Note that this symbol here is not equals as in mathematics. Rather, you can think of it as becomes 2 or is assigned to. And doing this is called assignment. Okay, and now we know we've got 2 stored in our x variable. Let's have a look at a more difficult assignment. So here we have x is assigned the addition of 2 and x. Now the important thing to note here is that the right-hand side is always evaluated first, and then the value is stored at the location given by the left-hand side. So on the right-hand side, we have 2 at plus x, and the value of 2 before this line was 2. So we have 2 plus 2, which gives 4, so 4 is stored in our x. Now one other thing we can do is we can assign and declare on the same line. So here we have int y is assigned 3. And this is called initialization. So one thing to note also is that once you've declared your variable, you can use it anywhere after it, but you cannot redeclare it in the same scope, which we'll look at later. Alright, that is it for this video. Thank you very much.